Okay, in the section 4 we will talk about translational and rotational mechanical system. In TF, Hamza, what is translational? Huh? Please speak loud. Huh? Yes, and so what is the rotational? Rotation. It's turning. The other one goes forward in one direction, right? And so we have, just like the previous one, we have the component. We have the relation of the force displacement. And we have the torque, angular, and also the impedance, guys, okay? So, first of all, we have give the watt, the force, and X is given in here, and K. What is this? This is spring, right? What's the relation between this component? What's the equation? Yes, Ft is equals to the what? K times Xt, okay? And so, in the torque, K times theta T, right? And so, what is the impedance in here? It resists to move, right? K. And so, just only K, because it's not time dependent, right? And so, in the second place, we have the C, and also define the X and F, right? What's the formulation? Ft, which is equals to the what? C times dxt dt, right? And so, in the torque mode or rotational mode, we have C, but in here, theta t dt. And in here, what's the transfer function of these terms? C times S, right? And also, we have the mass, right? Xt F, see? And Ft, which is equals to the m times Xt T over 2, right? This is the F equal ma, acceleration. And so in the torque mode, which is equals to J is inertia, right? And so d square theta t dt square, and so this is the ms square, right? This is the what? The Laplace transformation of the components of the mechanical system in terms of the what? Rotational and translational. Okay? So, yes, no, I couldn't upload to Learn because I don't have any email password in here, okay? But I'm uploading to the what? Classroom, right? Classroom. You don't have any classroom code related to this course? Okay, so just one friend tell about the classroom code, right? Google Classroom that we use in this lesson, okay? And so, the example, okay? Find the admittance of system given just like this one. We have these terms, and also the K, and we give the C in here, and M, X, T, F, T. And so, what is the equation of motion of this system? Aeon is Hamza. Yeah, no. So we have the given input and we obtain the output. What is the output? Output is position, right? And so Ft is equals to the what? If you pull this mass, this resists, and this resists. But in which way? To see that. And so this is the x0, and so if we pull this m, and so the deflection rate is equal to the what? Mx dot dot minus x0 dot, right? Because this is fixed, right? And so what about this one? C times x dot minus x0 dot, right? And k x minus x0, right? This is the equation of motion of these terms. But in this case, if the x0 fixed, and so this is 0, this is 0, and this is 0, right? Okay. So, in the second place, how can we write this term in terms of the what? Transfer function or the Laplace domain. If we take the Laplace transform for this section, and so Fs is equals to the what? Xs times ms square plus Xs, this is the dot, Cs, and Xs times K, right? Okay. So, in the third, if we have this notation, and then we can say that the Fs, which is equal to what? Xs s square Cs plus K, and at the end of this rotation, Fs 1 divided by ms square Cs plus K, right? This is what? Transfer function of length, right? Okay. And so we can obtain these terms just like this one. We have the three terms: mass, damper, and spring. And so each related to the what? To one component. And also it has the impedance values and impedance formula. And so we can pull these terms in here and we can generate to the what? Transfer function. The frequency domain, right? And after that we can analyze to what? To these terms. T, xt, maybe f is equal to 5, and so this going to the what? 5 divided by k, right? In here. We can analyze. Or, in the second example, we have x0 and we have the mass x k1 and we pull with the f and also k2 and x2, okay? And so how can we write the equation of motion of these terms? We have the input Ft, but what's the moving part in here? Mass. And so we consume some energy on these terms, okay? X0 and X2 are always constant, fixed, okay? Just pushing to the what? To the X. Okay, and so what about the other force? If you pull this F to the right hand side, which force produced on K1? K1 times X minus X0, right? And also K2, if you pull, and so the X is going to do this one, and X minus X1 happened at this moment. Okay? Both of them resist. Karşı mı geliyor yoksa destekliyor? Karşı geliyor. K2 o da karşı. Karşı geliyorsa benim verdiğim kuvvet bir kere bir tarafı ivmeye gidiyor, ivmelenmesine gidiyor. Diğer tarafı K1'e, diğer tarafı K2'ye gidiyor. Anladınız mı? Aslında hesap bu. K2. So, if x0 and x1 is equals to 0, and then we will have this equation, Q. F, x, yes, thank you, x, Q. Okay. And so, ft is equals to what? X dot dot plus x k1 plus k2, right? In the Laplace transform, we have the fs, which is equal to the what? M s square xs plus xs k1 plus k2. Okay? Okay? And so, what is the transfer function of these terms? Xs fs, which is equals to the what? 1 divided by ms square k1 plus k2. Okay? This is the transfer function. And also, please read Q.7 chapter in NISEP. Okay? 2.7 section in the NIS. Okay? So, any question? Okay. X0, X2 is 0 because it's fixed. Okay? Yani bunlar sabit olduğu için 0 alıyoruz. Ya onlar hiç hareket ettiği için sadece x'in değişimi her şeyi belli ediyor. Ama onlar hareket etseydi böyle olmayacaktı. Anladınız mı? Okay. So. Oldu. In the section 5, electromechanical system. What's the meaning of the electromechanical system? Hamza. Yes, just like, for example, DC motor, right? And so, in the DC motor, we have this body, just like this one. And also, we have the rod, and we pull this one to the K, okay? This is the GM, and also we have the friction factor CM, right? And we have also applied torque values in here, okay? So, in the analog, or we will call it in free body diagram, we have the what, just remember the system dynamic lesson, RA, and also inductance, which is given in here, and also VA or VB, back EMF voltage, right? This is called armature, right? Anyone remember that? This is the EAT. This is the applied voltage. And so, due to the back EMF voltage, this DC motor converts the electrical energy to the mechanical one. It rotates. Okay? So, in here, we have torque mt, right? And also, we have theta mt. And we have also a C value and the K value in here, the fixed body. Okay? And this is also J. We have the mechanical parts, inertia, damper, and the spring factor, rotational spring factor, and we have also electrical parts, resistance, inductance, right? And so, in order to use these terms, we should use the system dynamic. We should write the electrical system, we should write the mechanical system, and we need to combine this system onto what? The transfer function. This is a huge advantage to what? To analyze this system for a given voltage, how many rotation happens in this system. This will tell us. Okay? So, this is the first. And in the second, solving electrical system. EAT, which is equals to the what? IAT R, because we have the IAT current in here. And also just remember the inductance formula. LA times what? DIAT dt. And also we have the voltage, back EMF, VBT, right? And also we know that from the motor dynamics, KB times d theta mt dt, right? This is rotation. Yani back EMF voltajını siz ne yapıyorsunuz? KB diye bir katsayı var ve o motorun dönüş hızıyla çarpınca direkt doğrudan bir ilişki elde ediyorsunuz. Okay? And so, if this is the case, in the tree, we have this transfer function, EAS, IAS, RA plus LAS, because we have the derivative in term in here, and KB times theta ms times S, right? Okay? This is the first equation to relate to the what? Electrical system. Four. In mechanical one, we have to what? Torque mt, which is equals to what? Theta m dot dot jm plus cm theta m dot plus km theta m. What's the meaning of the km in here? Km, spring factor. Cm, damper factor in rotational. Jm, inertia. Right? So, if we take the Laplace transform of these terms, and so we will have torque ms is equals to theta ms jm s square cm s plus km. Right? This is the formula. But we have also one more formula. Just remember that in the representation of the DC motor, how can we represent torque in terms of the current? Just remember, torque equals to the what? KT times IAS, right? Torque equals to what? KT. KT is a constant, electrical constant. IS can be represented in this form. And so, using this form, in the 5, EAS equals to the what? What's the formulation of IS right now? Torque M divided by kt, right? You just put it, okay? And so torque M is divided by kt times Ra plus Las, right? Plus kb times theta M S times S, right? And so if we write all these terms in here, what is the torque MS? This one, right? If we put torque MS into this one, and so EAS, which is equals to what? Theta MS GM S square CMS KM, right? Divided by KT times RA plus LAS plus KB theta MS S. See, we have only theta and E, right? Voltage value, okay? And so, if we reorganize the whole terms one last time, EAS, which is equals to what? Theta M S JM S square CM S KM RA LAS divided by KT plus KBS from the equation 6. This is easy. Just collect the whole terms just like this, okay? So, what is the transfer function right now? The transfer function of these terms is equals to what? Theta MS divided by ES, which means that for a given voltage, how many rotation or degree happens in this system? Or in Turkish, ben 1 volt verdiğimde bu theta ne kadar hareket ediyor? Artık sizde bunun formülü var. We have this formula, okay? But this is electrical to mechanical. See? And so, we have the KT divided by JM S square CMS KM RA plus LAS plus KT KBS, okay? So, if we have this formulation, and then we can make some assumption. Yani bazı kabuller yaparak biz bu denklemi basitleştirebiliriz. Why? In 9, for example, LA is 0 and KM is equals to the 0. We don't have the no spring, and we can we can remove the LA factor because it's too small to analyze, okay? Yani motor taktığınız sisteme kolay kolay siz spring takmazsınız, yay taksınız. Ya da LA çok düşük değerlerde olur, o yüzden ihmal edersiniz. If this is the case, and so we can rewrite this equation, theta ms EAS, which is equals to what? The KT divided by S square JM RA plus SCM RA plus KT KBS. Okay? This is the formula of these terms right now. If you rewrite this equation in the 10 right now, the GS is equals to the what? KT divided by S JM RA plus CM RA plus KT KB. Just collect the S parts, nothing more, okay? And then what? If we divide both sides denominator and numerator with the Jm times Ra, and so we will get Kt Ra Jm S plus Jm plus Kt Kb Jm Ra. Okay, this is the last form. But if we say that this is the big K and this is the alpha, and so in the last form we can write theta ms divided by es, which is equals to what? The K S plus alpha, guys. Okay, and so the big K is equals to the Kt divided by Ra Jm. Okay, this is the reduced form of the motor formulation, and alpha is equals to what? Cm Jm plus Kt Kb Jm Ra. Okay, so this is what? This is just kind of first order system, but with the integrator. Okay, and so we can analyze this system in terms of what the time response after the what? Taking the inverse Laplace transform. Okay. Şimdi bakın arkadaşlar. Burada yaptığımız şeylerin içerisinde ne yaptık biz? Bir sürü hesap yaptık. DC oldu. Bir de Türkçe öğreteyim. Tamam. Hani hata olmaması adına notları zaten paylaşacağım. Şimdi bakın. Burada bizim bir elektrik motorumuz var. Bir elektrik. Bir de mekanik. Normalde biz bunları birleştiremeyiz. Ama burada birleştirebiliriz. Niye? Laplace. If we have any one electrical system and one mechanical system, we cannot combine into the one equation. But if we use the Laplace transform, we can do that. Because everything is in the form of what? S form. S form. Okay? And so, firstly, we need to use or solve the electrical equation. Electrical system. Yani elektrik denklemini biz yazıyoruz o komponentlerle birlikte. Verilen voltaj nereye harcanıyor? Bunların hepsini yazdık. After that, we are taking to the what? Laplace transform. In order to obtain the what? Frequency response. And after that, we have also mechanical system. Torque eşittir equals theta dot Jm plus Cm plus theta m plus Km theta. Right? This is a mechanical. And also we have also a transfer function here for the mechanics. Right? Şimdi bakın bundan sonra ne yapıyorum? Ya benim torque emesim buradaysa. Bak ben bunu aldığımda bu A'nın formülü neydi? Torque eşittir bir sabit çarpı akım. Değil mi? Ve diyor ki o zaman akım değeri torque bölü KT'dir. Anladınız mı? Evet. 5'te gidiyorum. Bak 3'teki denklemin içerisindeki akım yerine gidiyorum torque denklemi diyoruz. If we put the equation 3 into what? Into this terms, if we rewrite the current with the what? Torque divided by Kt in here. And so we can combine the 4 with 3, which yields to the what? A equals to the torque and Jms square blah blah blah. This is the what? This is the equation 4. Right? And after the Kt here, and so the rest of them is given 3. Okay? Yani biz iki tane denklemi burada birleştirdik arkadaşlar. And after that, we have only get E, voltage, applied voltage, and theta. Rotating degree for the motors. And so if this is the case, we can write the A, which means that for a given voltage, how many degrees are operating in time or in frequency domain. Değil mi? Yani ben bu denklemi çıkardım. Şimdi bakın bu denklemi çıkardım ama bu denklemde biz genellikle induktansı çok küçük olduğu için sıfır alırız. Motorlara da genelde spring koymayız, yer koymayız biz. bunları sıfır eşitlediğimde en son indirgenmiş denklemi buna gelir. Buna da. Benim kullanmam gereken parametreler bunlar. And after that, if this is the case, I can combine the whole system into one form. A divided by RG, blah blah blah, S times blah blah. This is important. We have two roots in here, right? One of 0, the other one minus alpha. These are the important parameters to analyze the time response of the distance. Yani bakın ben bunu bu formda yazmamın aslında bir sebebi var. Oradaki o kökler 0, S çarpı ya 0, kök ne demek? 0 eşitleyen ne demek? S artı alfa demek, eksi alfa bunun bir de kökü. Bu iki tane kök zamanda benim için önemli bir şey. Önemli bir anlamı var. 2 hafta sonra mesela bunları tartışacağız. Çok detaylı bir şey. O yüzden bu forma geldikten sonra artık siz bunu kontrol edebilecek duruma geliyorsunuz. Ya da daha güzel söyleyeyim. Bakın biz elektrikten başladık. Kalp mekanikten çıktık. Artık siz görebiliyorsunuz. Ya ben buna 5 volt verdiğimde bu kadar. Bunu diyebiliyorsunuz. Bunu diyebildiğiniz için biz bunu kullanabiliyoruz. Mesela bir araçta normal bir aracın içerisinde gaza basıyorsunuz. Bu adamlarda gaza bastığınızda bu aracın ne kadar hızlanacağına dair artık bir formül var. Yani böyle bir denklem çıkarmışlar ki aynı mekanikten elektrikten mekaniğe. Bir araçta da yanma ısıdan mekaniğe geçiş var. Anladınız mı? Nasıl konu bu? Bu frekans dolayı işte bu işi. Sorusu olan var mı?
Previous slide. Can we go to the previous slide? So we always take LA as 0.
No. If you have a meaningful delay, you cannot do equalize to 0. But in a normal DC motor, we can do it. If you don't have the spring and so, you can take the 0. But if you have a spring and so, you cannot take the 0. This is a complex representation. But if you have a simple DC motor and so, you can make some assumption like just like that. Okay? Yani bu varsayımları sizin kendi durumunuza göre yapmanız lazım arkadaşlar. Anladınız mı? Bu en iyi. Assumption'dan sonra daha da basitleşiyor. Sorunuz var mı? Eğer sorunuz yoksa arkadaşlar bugünlük bu kadar. Çünkü sizin bir de 2 saatlik bir session'ınız varmış. Yarın o soru çözümü olacak arkadaşlar. Bilginiz olsun. Anladınız mı? Tomorrow you will have a question and answer session. Okay? So I'm breaking in here just now because I have the 4 questions to be solved in your assessments. Okay? Yes. Arkadaşlar biri sınıf kodunu verebilir mi ya? Dur bakayım bir dur.